So today we discuss about this chapter, okay, topic. So in the previous class we discussed about the Bohr's atomic model, and Bohr's model of atom we are completed in the last class. This is the Bohr's atomic model. According to Bohr's model, electrons revolves around the nucleus in a specified circular paths, which are called as the orbits or shells. And these are the orbits, or shells, and these are named as K, L, M, N, and so on. How they are named as K, L, M, N, and so on. Okay. And thus, as long as electron revolves in its particular orbit, their energy is constant. Hence, these are called as stationary orbits. Okay. So this we discussed. Now, let us see the next topic is neutrons. So we already discussed that atom consists of mainly three fundamental particles. Yes or no? Electrons, protons, neutrons. Right? Yes or no? Electrons, protons, neutrons. But here electrons were discovered by J.J. Thomson in the year 1897. Okay, and protons also discovered in the same area only. But neutrons were discovered later. Okay, so neutrons were discovered by the James Chadwick. Okay, James Chadwick was the person who discovered the neutron in 1932. And a neutron is one of the fundamental particle with its mass is equivalent to mass of proton or approximately equivalent to mass of hydrogen, but it do not carries any charge. It is neutral particle. Okay, so it is neutral particle. So hence, the charge on the neutron is 0. Okay, so and when you see, already we discussed that we have 118 elements. In that 118 elements, except the hydrogen, remaining all elements consist of neutron. Okay, except the hydrogen, remaining all consist of neutrons. Is this clear? Right. So that is about the, and these neutrons where they are present in the nucleus with the protons. They are present in the nucleus along with the protons. So hence, as the protons and neutrons both are present in the nucleus, these both together are called as nucleons. What they are called? Nucleons. Okay, so that's all about this one. So 1932, Chadwick discovered another particle called as another particle called as a neutron. Okay, and see here, it has no charge. This is most important point here. It has no charge. It is neutral and mass nearly equal to proton. So as it has no charge means neutral. So that's what it was called as a neutron. Okay, and see neutrons are present in the nucleus of all atoms except the hydrogen. Remaining all atoms consist of neutrons. And the mass of the atom is due to sum of the protons and the neutrons. Sum of the protons and neutrons constitute the nucleus. So the total mass of the nucleus is due to protons and the neutrons. Is this clear to you?
Yes, sir.
Right. Now then come to the, this is electronic configuration. Do you know about the electronic configuration?
Yes, sir.
Yeah, electronic configuration means the systematic arrangement or the systematic distribution of electrons in the various orbits of an atom is called electronic configuration. Okay, you know that atom consists of electrons, protons and neutrons. In that protons and neutrons are present in the nucleus, electrons will be revolving around the nucleus. Yes or no? And according to Bohr, electrons will be revolving around the nucleus in specified circular paths like K, L, M, N and so on orbits. Okay, so now in these orbits, how these electrons will be distributed? Okay, whether all orbits can accommodate same number of electrons? No. Okay, the first shell, for example, take the K shell, that accommodate only 2 electrons. Okay, and if you take the L shell, it can accommodate 8 electrons. Okay, so here you see this is the first shell, K shell. This K shell can have only 2 electrons, maximum of electrons 2, maybe 1 or 2. Okay, but if you go to the L shell, it can accommodate 8 electrons. Maximum of how many electrons? 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So like this, okay, all electrons cannot accommodate the same number of electrons. Okay, so the different orbits can accommodate different of electrons. Okay, so that systematic distribution of electrons in the various orbital of an atom is called electronic configuration. So the distribution of electrons in the different shells of orbits. Okay, so here now already we discussed in the Bose model that the first shell, okay, the first shell K value is given as 1, the second shell L value is given as 2, the third shell M value is given as 3, the fourth shell N value is given as 4. So every shell has one particular number is given to you, yes or no? And this number actually it is denoted by principal quantum number. There is one quantum number, but that you study in the higher classes. Now we are not going to discuss about that one. So let these numbers are denoted by n. Imagine that these numbers are denoted by n. So here the maximum number of electrons that can be accommodated in any orbit is given by the formula 2n square. What is the formula? 2n square. So 2n square. So here I am writing 2n square. Okay. For example, you see here K shell. How many electrons it can be accommodated? So you write here 2 into n square. But K shell value is what? 1. So 1 square. 2 into 1 square. 1 square is 1. 1 into 2, 2. So first shell can accommodate only 2 electrons. Is this clear to you? Right. Now come to the second shell, L shell. L shell number is what? L shell number is 2. So here you write the formula 2 into n square. But n is 2. So 2 square. So 2 square is 4. 4 2s are 8. So second shell can accommodate how many electrons? 8 electrons. Now let's see the M shell. M shell number is what? 3 here. So here what you write here? So how much it becomes? 18. So M shell can accommodate 18 electrons. Now what is the N shell value? Now how many electrons can be accommodated in the N shell? Maximum number of electrons? 32. Very good boy. So 2 into 4 square. That is 4 square is 16. 16 2s are 32 electrons. Very good. So this is the distribution of electrons. So in orbit number n, if orbit number n, then the number of electrons present in the orbit is given by 2n square. The formula is 2n square. Remember that. Okay. So for n is equal to 1, maximum number of electrons present is 2 into 1 square and so on. Okay. So in this way we can fill the electrons. Is this clear to you?
Yes, sir.
Right. You can take the screenshot of this one.
Yes. Yes, sir,
Taken? Right. Now, let us see the valency. What is the valency? Already we discussed. Valency means?
Expressing in the outermost cell of
Yeah. So, in simple way, if you would like to say what is valency, the combining capacity of an atom is called valency. What we can write there? The combining capacity. The combining capacity of an atom is called valency. Some other definitions also I gave in the previous classes to you. So, valence can also be defined as the capacity of an atom to combine with the number of hydrogen atoms. That is also called valency. Or the capacity of an atom twice the number of combining with the oxygen atom. That also called valency. Okay, here the simple definition is the combining capacity of an atom is called valency. Or you can say that the number of electrons, that atom can lose or gain to attain stability is also called as a valency. So, you can give number of definitions to the valency. Okay. Now, what are the valence electrons now?
the number of electrons present in the
outermost shell. For example, if you say I have sodium, okay, you know sodium atomic number is 11. If I write the electronic configuration, I'll write 281. So outermost shell means what? Last shell. This is the first shell, second shell, third shell. The last shell, how many number of electrons are present? This is called the valence electrons. This number is called valence electrons. For example, if I take the oxygen atomic number is 8. So I write the electronic configuration 2, 6. So here the valence electrons is 6. Is this clear? So the electrons existing in the outermost orbit an atom is called valence electrons. Outermost orbit means what? Last orbit. The last orbit, how many electrons are present, and that is called as a valence electrons. Is this clear? Next, the atoms, okay, which have completely filled in the outermost shell are not very active chemically. This is most important point. So here we already discussed about the noble gases or inert gases. Did you remember? So can you give some examples for the noble gases? Like helium, neon, argon, krypton, xenon, radon. These are the examples of inert gases, or we can say noble gases. Okay. So these noble gases speciality is that their outermost orbit is filled with 8 electrons except the helium. Except the helium, the remaining all filled with 8 electrons. If they have 8 electrons means what? That is called octet configuration. What is called? Octet configuration. The elements with octet configuration are stable. Or what? Stable. They are inert. They do not react with other elements. Okay. So they do not react with the other elements. So you can see like oxygen can react with hydrogen, oxygen can react with carbon, oxygen can react with silicon, oxygen can react like this, oxygen can react with so many things. Now hydrogen is also there, hydrogen can react with oxygen, hydrogen can react with nitrogen, hydrogen can react with okay, phosphorus, like this, okay, it also combined with it. So like this, all elements are combining with each other, okay, so they are active. And whereas these noble gases, these gases do not react with other elements, okay. Of course, if you go to the higher classes, you will learn some compounds of xenon, but as of now, okay, so these elements do not react with the other elements, okay. So they are very less active in nature, okay. Why? Because except the helium, they all having 8 electrons in their configuration. So that is called octet configuration. The elements which have octet configuration in their outermost shell, they are stable. So the atoms which have completely filled. So when we say that there is octet configuration, the meaning is what? It is have completely filled with outermost shell or not very active chemically. Is this clear to you? Right. And the valency of an atom, just now I told you that the combining capacity of an atom, here the definition is given. Okay, that is about the valency. Okay. Now, come to the atomic number. I think we discussed about the atomic number in the previous classes, I think, no. If not, okay, no problem. What is atomic number?
The number of protons present in the nucleus of an atom.
Very good. The number of protons present in the nucleus of an atom is called as an atomic number. Okay. And this atomic number is also equal to the number of electrons revolving around the nucleus. Okay. If you take any neutral atom, how many protons are present in the nucleus? The same number of electrons will be revolving around the nucleus. Okay. So here the most important thing is that the chemical properties of the elements are depend on the number of protons. Is this clear to you? This is very important. The chemical properties of the elements is depend on what? Number of protons. Okay. So if we say the hydrogen, so hydrogen means 1 proton it has. If we have 8 protons in any atom, that is definitely oxygen. That is definitely oxygen. Okay. So one atom can be identified, okay, by its atomic number. And atomic number is nothing but a number of protons present in the nucleus. And atomic number is denoted by the letter Z, capital letter Z we use, okay, to represent the atomic number. Is this clear to you?
Yes, sir.
Right. and atomic number is also equal to number of electrons present in the means revolving around the nucleus in the neutral atom. So, if the protons, how many protons are there? Same number of electrons are there, and you know that protons carries a positive charge, electron carries a negative charge. So, this protons is equal to electrons. So, the meaning is what? The amount of positive charge is equal to amount of negative charge. Hence, the net charge in the atom is 0. That is called neutral. Is this clear? Every atom is neutral. Every atom is naturally they are neutral. Okay, but while combining with other elements, some elements may lose or gain the electrons. Right? So that is important. So see here, atomic number of an element is equal to the number of protons, present in the nucleus of an atom. Okay, and since the atom is electrically neutral, see here, since the atom is electrically neutral means what? It do not possess any positive or negative charges. Okay, so neutral, thus the number of protons and number of electrons are equal. Okay, number of protons and number of electrons are equal. So the meaning is what? The amount of CR, atomic number is equal to number of protons, that is nothing but a positively charged particle. Number of electrons are what? Negatively charged particle. The amount of positive charge is equal to amount of negative charge, hence atom is neutral. Clear?
Yes, sir.
Good. So take the screenshot of this one. Okay. Right. So this is about the valency and atomic number. Next, after atomic number, it comes to mass number. What is the mass number? Just now I discussed while explaining the neutron.
Sir,
What is mass number?
the number of protons and neutrons present in the nucleus.
Very good. So here already discussed in the while explaining the neutrons today in the first slide also. So here atom consists of electrons, protons and neutrons. Yes, in that term these protons and neutrons are present in the nucleus and electrons will be revolving around the nucleus. Yes or no? Okay. So this mass number means what? See here, the mass of the electrons is negligible, very less. So mass of the proton and mass of the neutrons are almost equal to the 1 AMU, 1 atomic mass unit or 1 unified mass. So here the protons and neutrons both are present in the nucleus and the sum of the protons, sum is what? Addition. Addition of number of protons and number of neutrons is called mass number. Is this clear? Mass number? The total number of, total means what? Sum of addition, sum of also you can say. Sum of protons and neutrons present in the nucleus of an atom is called mass number and it is denoted by the letter A. It is denoted by the letter A. Okay. So, and see already this point I told you that protons and neutrons both are present in the nucleus, hence they are called as the nucleons. What they are called as? Nucleons. They are called nucleons. Okay. And generally the number of protons is represented by the letter N. So that is about the mass number. So mass number means the sum of the protons and neutrons is called as a mass number, and protons and neutrons both are present in the nucleus. So hence they are called as the nucleons. Okay. And protons also mass number can be here written off. So mass number is presented with A and A is equal to sum of the protons plus neutrons. Okay. And A is equal to sum of the protons. So a proton, number of protons is also called as atomic number. In the previous slide I explained you. Okay, number of protons is called atomic number. Number of protons in the nucleus is called atomic number. So now what I do, in the place of protons I write atomic number. Atomic number is denoted by Z. So Z plus N like this. Okay. So like this. If I want to find the N, if I want to find the number of neutrons, then what can I do? A minus Z. So from the mass number, if I subtract the atomic number, then I will get the number of neutrons. I will get the number of neutrons. Is this clear?
Yes, sir.
So this is very important. So see here, this I think already explained, but once again, for example, if you say carbon is there, okay, normally if you see the carbon, generally carbon will be represented like this. Do you know this one?
Yes, sir.
So here the meaning is what? Here that as a subscript down, what is the number is there? This is atomic number. What it is?
Atomic number.
And as a superscript, what is the number is there? That is called the mass number. What is that?
Mass number.
And if we want to know how many protons, how many electrons, how many neutrons are there. So for example, we wanted to know the number of protons. So you know that, excuse me. Okay, number of protons is nothing but atomic number. The previous slide you have seen, the number of protons is equal to atomic number. Yes or no? So number of protons is equal to number of atomic number. Atomic number is what? 6 here. So number of protons is equal to 6. Okay, and how many electrons are there? 6 only, because see number of protons is equal to number of electrons is equal to is there. So the meaning is what? 6 electrons. Now how many neutrons are there? 6 only, because now I give the formula here. N is equal to A minus Z. Here A is 12, Z is 6, 12 minus 6 is 6. So like this you can represent the element, and by seeing that representation we can say that what is its atomic number, what is its mass number, how many protons are there, how many electrons are there, how many neutrons are there. Is this clear to you? Right. So that is about the mass number. Now let us come to the isotope. Do you know what is the isotope? So isotope means what? See, very simple here. Atoms of same element. See, a very simple. Atoms of the same element having same atomic number but a different mass number. Okay. So here 2 points mainly you see. Same atomic number but a different mass number. Same atomic number but a different mass number. So elements or atoms which are having same atomic number but different mass numbers, they are called isotopes. Is this clear to you?
Different number of neutrons.
They all have different number of neutrons. Atomic number same. Atomic number is nothing but a number of protons. So number of protons means the same. But mass number is different. Mass number is what? Sum of the protons and neutrons. So meaning is what? Neutrons are differing. So atoms with the same number of protons but a different number of neutrons are called isotopes. Is this clear to you? Now see, normally so many elements are exist in different forms like isotopes. So many elements have the isotopes, but here the example is given like hydrogen. So hydrogen normally exists in 3 forms. Okay, normally hydrogen exists in 3 forms. Okay, so one is called I rub this one. It's not going. So normally hydrogen is available in the nature in 3 forms. Okay, one is hydrogen 1,1, hydrogen 1,2, hydrogen 1,3. Okay, like this. So just now I told you that the number which is as a subscript means down, they are called as what? Atomic number. That is called what? And the number which is at top, they are called mass number. What they are called? Mass number. So now for here, for these 3 hydrogen atoms, if you check Z and A, so Z is 1, for here also Z is 1, Z is 1. So atomic number same. But mass number you see here A is 1, but here A is 2, here A is 3. So mass numbers are different. But all are hydrogen atoms only. Why they are called all are hydrogen atoms? Because just now I told you that if it is atomic number 1 means that is hydrogen only. Okay, the chemical properties of the elements will be depend on the number of protons. Just now I told you, the chemical properties of the elements are depend on what? Number of protons. One element is identified by their the number of protons only. I just now I told you, if 8 protons are there, means definitely that is oxygen only. So the one element is identified by with what? With their atomic number, and atomic number is nothing but the number of protons. Remember that. Okay. So now here 3 are hydrogens only, but here atomic numbers. Why there 3 are hydrogens? Because atomic number remains same, but mass numbers are differ here. Okay. So why the mass numbers is differ? So this is nothing but a atomic number is nothing but a number of protons. But if you see the number of neutrons, I said okay, 1 minus 1 0, 2 minus 1 1, 3 minus 1 2. So here neutrons, they are differing in the neutron. And just now I told you that while explaining the neutron, hydrogen is the only element in which there is no neutron. Okay. So only element without neutron is hydrogen. Okay. So here you see now the atoms of same element. See, same element, hydrogen, 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 having same atomic number 1, 1, 1, but a different mass numbers. So 1, 2, 3. So these are called isotopes. What they are called? Isotopes. So here the hydrogen with atomic number 1 and mass number 1 has another name, that is called protium. What it is called? Protium. And second hydrogen, hydrogen with atomic number 1 and mass number 2 is called deuterium. What it is called? Deuterium. And third one, hydrogen with atomic number 1, mass number 3 is called tritium. What it's called? Tritium. So these are the 3 isotopes of hydrogen. Is this clear to you?
Sir, you said hydrogen is the only one element which has no neutrons.
Yeah, now in this atom, this hydrogen if you take, so there are no hydrogens. Now there are no neutrons.
What about deuterium and tritium?
Of course, deuterium and tritium, there is a neutrons are there, but in this particular hydrogen atom, see, mostly in the nature you get this type of hydrogen only, not these two.
Yes,
Okay, mostly the nitrogen is available in this state only. Okay, so that's what here, this only we consider, and in that term, no neutron is present in it. Is this clear to you?
yes, sir.
So this is the isotopes. So isotopes means what? Atoms of same element with the same atomic number but different mass numbers are called as the isotopes. Now whether these isotopes only in hydrogen only present? No. So many elements have the isotopes. So many elements have the isotopes. Like carbon also. Just now we are discussing about the carbon. So carbon also has isotopes like C612, C614. So these two also carbon only. Okay. This is normal carbon. This is called radiocarbon. Okay. So like this, so many elements are there. They have very good uses. Okay, like uranium is there. Uranium also has isotopes. Uranium is used in the nuclear reactors. Okay. So like this, so many uses are there. Okay. So this is about the isotopes. Take the screenshot of this one. Done? Chalo. Now next come to the application of isotopes, where we use the isotopes. So see isotopes of uranium used in the nuclear reactor as a fuel. Nuclear reactor. This you learn in the 12th standard. You have the nuclear physics. So in that you will learn. So here nuclear reactor means what? A device which is used to control the chain reaction is called as a nuclear reactor, and that you learn in the higher classes, don't worry. So there, okay, uranium, isotope of uranium is used. And similarly, isotope of cobalt is used in the treatment of cancer. See, very important. Okay, so isotope of cobalt is used in the treatment of cancer. Next, isotope of iodine is used in the treatment of goiter. Okay, so goiter. Okay, this is come. So here these are the applications of isotopes. Not only this one, so many applications are there. So they can be used in the meteorology. The meaning is what? In the study of atmosphere. They use in the medicine. They're in the technology industry. So many uses are there. But here they give, okay, they give only 3. Okay, so these are the isotopes of applications. Okay, now last and final topic is isobar. Isotope we studied. Isotope definition, what I said? Atoms of same elements here. So here, if you want the definition of isobar, just you reverse it. Where the same word is there, make it different. Make it different. And where the different is there, you make it same, then that becomes the isobar definition. So how can you define? Atoms of different element having, here also same is there or different? Different atomic number but same mass numbers are called, okay, isobars. Is this clear? Just change the definition, okay? Just change the definition, just change this word, same, wherever the same is there, you write the different, wherever the different is there, you write the same. So that gives a definition of isobars. Here, see, atoms of different, there what was there? Same. And same mass number same, but atomic number should be different. So these are called isobars. So examples here, here you see 3 elements are given, potassium, argon, and of course calcium is also given. Okay, so here if you see here, argon and calcium, let us take argon and calcium. So see here, the number down it is given, see here like this, argon and here calcium, see number what is given, 18 and 40, 18 and 40, and here it is given what, 20 and 40, 20 and 40. Now this below numbers are called what? Atomic numbers. And this superscript numbers are called what? Mass number. So here atomic numbers are different. Elements also different. Only mass number remains the same. So these are called isobars. These are called what? Isobars. Isobars. Okay. So take the screenshot of this one. Okay. So I think with this the chapter is done. Okay. So the chapter is done. So structure of atom, the chapter is very important chapter. If you go to the higher classes, in the 10th class and enter first year, means 11th standard, everywhere the structure of atom is there. Very important chapter. And even in the main IIT, when you write the IIT, so there from most, okay, at least 2 to 3 questions you get from this atomic structure. Okay. So that's what's a very important chapter. And whatever the notes is given to you, prepare that notes very perfectly. And in the next class, I am going to start the new chapter, that is atoms and molecules. And in between any time, I am going to give one worksheet. We are going to solve some questions from this one. Okay?
Yes, sir.
Right. Okay then. So we stop the class with this because 6:35 done. Okay. I have one more class at 6:40. Okay. Okay then. Bye.
Sir,
Yes. Any doubt?
where can I get this PDF, sir, which have this all these slides?
Slides, okay, I'll check out with the technical department. If it is possible, I'll ask them to send you. Okay? Right. Okay, you can leave and join in. After 5 minutes, you join. Okay.